Hello guys, welcome back. Today we are going to talk about linear data structures. In previous video, we learned about the introduction of data structures, and today we are going to learn about linear data structures. I told you in linear data structures there are four types: stack, queue, linked list, and arrays. Today we are going to learn about what is mean by stack, right? You can call stack as a container too. What is stack? Stack is in stack only limited access is possible, right? And in stack the data is arranged in a sequential order, right? I will later show you the logical representation of the stack. In stack, you have a rule for insertion and deletion of the data. That rule is you can insert, delete data only from one way. Only from one way. Right? This is the rule. You must get in this, right? As an example, we will take a real world example, a CD stack. Right? You can insert CD from the top and you can remove the CD from the top, right? So if you want to remove this one, you have to remove this one and this one. That is the rule. Insertion and deletion is possible only from one end, right? And this is the logical representation of stack. Right? You call LIFO. That means last in, first out. So this is only the logical representation, not is the real representation. There are some operations done in stack. Those operations are push. Push means insertion of data. Insertion of data. And pop. Pop means deletion. Deletion of data. And peek means it is not deletion, we are accessing the topmost element, right? Access the top element. Peek means accessing the topmost element. We are not deleting, right? And then the other function is empty and is full. I will show in an example. I will show this in an example. So in push operation, you can pass an argument, right? But in pop operation, you don't need to pass an argument because in pop it is removing the topmost element, right? Earlier I said that insertion and deletion is only from one end. So in deletion, that means in pop, the topmost element is selected and it is removed. So for that, no arguments need to be passed, right? So let's take an example for that. So in stack we are taking top first. In first we are taking top as -1 equals -1, right? That means somewhere here, and we are putting 0, 1, 2, 3 and 4. So here there are 5 elements, 1, 2, 3, 4, 5. And now I am assigning n. N equals 5. The size is 5. Right? So now first of all, when we apply pop operation, you can see this stack is empty. When I apply pop operation, you can clearly see the stack is empty. The underflow condition will apply because the stack is empty, right? And now I will do push operation, right? Push number 2, right? So earlier I said top is equal to -1, right? So when 2 is not there, top is equal -1, and then we are going to push 2. That means insert 2. Then we are getting top plus plus, right? Then the -1 is this -1 gets 0 because -1 plus 1 is 0, right? Then after that 2 is coming here, right? Then we will insert another element, push 3, right? Then again, now this is in 0, 0, and when we again do top plus plus, this become 1, right? Top plus plus, this become 1, and 3 is inserting here, right? Now this is the way you are going to do push operation. And now next we will see pop operation, right? Pop. So you can remember that in earlier I said that you need not to pass an argument. That means you need not to call an argument because in pop the topmost element is called. So when I apply pop operation, this 3 is removed. That means top minus. Then this 1 becomes 0 and this 3 will be removed. Right? And again, I'm doing pop operation. Then again, top minus. Then this 0 becomes -1. 2 will be removed and this 0 becomes -1. And if we call again the pop operation, what is the condition? The underflow condition will occur, right? Now it is the pop operation. I will give you something in push operation that I forgot one thing. So suppose you have 2, 3, 5, 7 and 8, right? Now you can see the stack is full, right? This whole stack is full. If we again do a push operation, push 10, right? And you can get this as n-1. N is 5, n is equal 5. n-1 is 5 minus 1 is equal 4, right? This is 4. That means stack is full and overflow condition will occur. Overflow, right? This will occur when the stack is full. And now we will move peak. Peak. Peak means it's simple. You are going, if you do peak operation, you are calling number 8. 8. 8 is short, right? We are not deleting 8. We are attending the topmost element. That is the operation done by peak, right? So now I taught you some operations. Push operation, pop operation, that means push means insertion of data, pop means deletion of data, peak means access the topmost element without removing, deleting, and is empty, underflow, is full, overflow, right? Next I will tell you the implementation of this. Okay guys, now we will move up with the stack implementation, right? Now I'm going to implement the stack using array. That means we are using static memory allocation. So you can use dynamic memory allocation also, but we must use in dynamic memory allocation, we must use a linked list, right? Now we are going to implement using arrays, right? For that we want static memory allocation, right? First of all, before we are moving to the implementation, I forgot to tell you about some applications. In my previous video also, I talked about some applications. One application is you can do redo and undo function, and in recursion, right? In recursion also you can use stack. That is the second one, and I will give some more when checking parenthesis balance. That means this parenthesis balance you can use stack, right? So now we will go to the implementation of stack, right? So first of all, I'm declaring some global variables, right? First, I have defined the size, right? N is 5. The size is 5, and this is the implementation of array, right? Int array name and the size. My array name is stack. Int stack and the size. The n is 5, right? And int top is equal to -1. Previously I told you that the top is equal to -1 in empty stack, right? So these three we are putting in global, right? Now, so I told you about some operations. In here, I will teach you 3 main operations. That means push, pop, peek, the implementation. In previously we talk about these operations, and now by implementation I will teach you these 3 operations, right? First, we will move on with the push operation, right? What is push? Push means insertion of data. In here, you can also call an argument that the way you prefer. Now, I will do in this way, right? I'm calling a variable x, int x, and then print. I'm putting a printf, that means enter the data you want, because push means insertion, and I'm printing this scanf, right? We are going to check a condition, right? I previously told you about this. If top is equal to n minus 1. What is n minus 1 means? N is 5 and 5 minus 1, that it means 4. Right? What is the condition? If n minus 1, remember that we are going to insert. We are checking this condition means we are checking is the stack is full, right? if top is equal to n minus 1, print overflow condition. That means you can't insert data because the stack is already full, overflow condition. Else top plus plus, right? And we are inserting the data, right? Stack top is equal to x, this variable, right? This is the push operation, right? And now I will going to teach you the pop operation, right? So in pop operation, what is pop operation? Pop operation means the deletion of data, right? Here you don't need, I told you previously, you don't need to pass argument, right? Because the topmost element is selected, right? So you don't need to call an argument here, right? In here, we are again going for condition. If top is equal to minus 1, right? That means what? We are checking, is this stack is empty. Top is equal minus 1 first. Top minus 1. Right? We are checking the stack is empty. If the stack is empty, what is the condition? We are calling underflow condition because you can't delete because the stack is empty. First of all, if top is equal to minus 1, printf, we are going to print underflow condition, stack is empty. Else, top minus minus. So here if you have 2 and you can see the stack is not empty, you have data here, and else we are going to do top minus minus. Now here it is 0. When you do top minus minus, this 2 will go out, and again this stack will become minus 1, right? Now this stack is empty, right? This is the way that you are going to do the pop operation, right? At last, I'm going to tell you the peak operation, right? Peak. The peak operation that I previously told you. In here, we are going to access the topmost element, right? Without removing it, right? So here also we are checking if top equals minus 1, right? Minus 1, because to check whether the stack is empty, right? Because when the stack is empty, then there are no data, so you can't access the top element. If the stack is not empty, we are going to else part and print stack. Print the top element of the stack. Print the top element in the stack, right? If you have 2 here, this is the top element. Only 2. This is the top element, and when you call this peak operation, number 2 is access, right? Number 2 is there, right? So these are the main 3 operations in stack, right? Push, insertion, pop, deletion. Here no arguments are passed, and peak, accessing the topmost element without deleting, right? So I hope you will get some knowledge about stack keys and linear data structure, and now we use stack implementation using arrays, and there are operations in that: push, pop, peak, and previously I told you about the is empty and is full operation. So I think that you will get better understanding about stack. So in next video I will tell you about non-linear data structure. Bye guys.